T and Y obey the law of the nonlinear equation y equals ae to the negative bt. Write that down here. Y equals a e to the negative bt, okay, where a and b are constants. Pairs of t and y are recorded from an experiment and recorded in table 3.1 below. Okay, so we see that. They said 1. Transform the nonlinear equation into a linear form. Alright, so with this now, you know that this equation is an exponential equation. To transform it into linear form, we use logarithms, alright? So you log both sides. In this case, you find the log. In this case, it's ln, not log. So ln y is equal to ln a e to the negative bt. Now, you use the laws of logarithms to rewrite this. Notice this is ln of 8 multiplied by e to the negative bt. Now, you remember the law of logarithm that says when you find the log of the product of two numbers is equal to the log of one plus the log of the other. Just as a reminder, suppose you say ln of 5 multiplied by 6. That should be equal to ln 5 plus ln 6, right? Let's see how that would work out. 5 by 6 is 30. So ln 30 equals 3.401 and so on. Alright, so let us find ln 5. Oh no, something here. Yeah, the thing jumped. Why is it jumping all over the place? No man, something is wrong here. Having some technical issues. Let me see something. What's going on? Let me see if I can fix this thing. Oh boy. Sometimes these technology give you a problem. Alright, I unplug it back in. Let's hope that it doesn't give me any more problem. Alright, so ln 5 plus ln 6 equal, right, 3.401 and so on. Same thing. So you can write this as ln y is equal to ln a plus ln e to the negative bt. Alright? But then the other thing is, you have ln of a number to a power. That's the power there. Now, you remember how to deal with that. Let's just erase this because this was just to remind us of something. How do you deal with this part? Remember, when you find the log of a number to a power, it's the same as the power times the log of the number. Suppose, for example, you find ln 5 to the power of 3. Then it should be 3 times ln 5. Let's see if it would work out. 5 to the 3 is what? 5, 5, 25, 25, 125. So you have ln 125 is 4.828 and so on. Alright. Now 3 multiplied by ln 5 equal. Right, same thing. So you multiply the power time the log of the number. So ln y is equal to ln a plus negative bt ln e. We know that ln e is 1. So ln y is equal to, let's put this in front, negative bt plus ln a. Now it's somewhat like y is equal to mx plus c, where c is the y-intercept. In this case, ln a is the y-intercept. M will be the gradient. In this case, t took the place of x. So negative b equals a dient, the gradient, right? So that is our thing there, our equation, our nonlinear equation. After that, they say draw and use an appropriate graph to estimate the values of p and q. Now this part is only 4 marks. It is 4 marks, good. But this part, it should be more than 6 marks. Drawing graph is a lot of work, you know. And with this. Anyway, I have a graph paper up here. See if we can use it somewhere here. And deal with the graph part of things. Let me expand the graph paper. Alright, so we have ln y equals negative bt plus ln a. Now, this is the graph of the nonlinear. We have t there, but y will be changed to ln y. Alright, so instead of y, we use ln y now. Alright, so let me see now, we're going to deal with this. Let's copy this table here. Copy. And paste it here. Let's drag this down. I'm going to make life a bit easier if we just have this table by itself. Alright. So instead of y, instead of plotting t against y, if you plot t against y, you're going to get a curve. It's a nonlinear graph, right? I plotted this before as it is, and it stays somewhat like this. But it's now linear. And we're plotting ln y equal negative bt plus ln a. Now, remember, ln a would be the y-intercept, negative b, the gradient. But instead of y now, we have ln y. So let's see how this is going to go. This will be ln y. Let's just extend parts of the table. For our ln y part, alright. No. Alright. So since it's so many, I'm going to just deal with it using my calculator off screen. So 7.5 ln is 2. Let's write 2 on decimal place, 2.0. 6.2 ln is 1.8. 5 ln is 1.6. 4.5 ln is 1.5. 3.7 ln is 1.3. 3.2 ln is 1.2 to the 2 decimal place is 1 to 1 decimal place 1.2. 2.6 ln is alright, it's 0.955, but it would be 1.02 1 decimal place. 2.5 ln is 0.9. 2.3 ln is 0.8. 2.1 ln is 0.7. 2 ln is 0.69 something, but it's also rounded off to 0.7 to 1 decimal place. Alright, so if we use that as our graph, t is 0. Alright, so t goes from 0 to 1, and t would be on the x-axis. So t have 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. Alright, so 0.1, 0.2, 0.3, 0.4, 0.5. Alright, we have to skip some of the numbers. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, it would be here, 0.8 here, 0.9, 1.0, okay. And then ln y goes from a low of 0.7 to a high of 2. Let me see something. Suppose we have that's 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.9, 1. No. Alright, 0.1, 0.2. This might make it. We have 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1.0, 1.1, 1.1. This is 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9, 2.0. Okay. So we see what happened here. See 0, 2, we have 0, I'm going up to 2. Then we have 0.1, 6.2, 0.1. I will go to 0.1, 1.8, 0.1 is 0.1. I will go to 1.8 right here. So there. Then we have 0.2, 1.6. This is 0.2. I'll go to 1.6. Should be right here. Then we have 0.3, 1.5. So we have 0.3, 1.5 is here. Then we have 0.4, 1.3, 0.4, 1.3 is right here. 0.5, 1.2, so 0.5, 1.2 here, okay. 0.6, 1.0, so I have 0.6 and 1 right here. 0.7, 0.9, so I have 0.7 and then 0.9 right here. 0.8, 0.8, 0.8, 0.8, 0.9, 0.7, so I have 0.9, 0.7, 1.0, 0.7 as well, 1.7. Well, we know that it would go a little bit down, but anyway, would still put it there, but due to the rounding off, it's an outlier. Alright, so we plot our line of best fit. Let's say it is somewhat like this. Alright, so y-intercept, it looks like 1.9, call it our 1.95. So the y-intercept as ln A, so the y-intercept is equal to ln A, it is 1.95. If ln A is 1.95, e to the ln A equal e to the 1.95. So it's an anti-log of them. E to the ln number is given the number, so A is equal to e to the 1.95. What is e to the 1.95? Let me just do it off the screen on my calculator here. So 1.95 e to the dot, about 7, I'll call it 7. A is equal to 7. Alright, the gradient, negative b, so gradient. Alright, so let's use 2 points for the gradient. Let's use 0.8, 0.8 and 0, 1.95. Alright, 0.8, 0.8 and 0, 1.95. Going to, let me drag this down a bit to make space. The gradient B. Or run out of scrolling space, so let's continue over here. So gradient is equal to, let's say this is x1, y1, x2, y2, y2 which is 1.95 minus y1 which is 0.8 over x2 which is 0 minus x1 which is 0.8 is going to be, now 1.95 minus 0.8 gives us 1.15. That's 1.15 over negative 0.8, which is going to be negative 1.438. Negative 1.438. So that's negative b. So if negative b is equal to negative 1.438, 1.438. Then positive b is equal to positive 1.438. Now remember the question here, it says the value of p and q, but that was an error in typing. It's really a and b that you want to find. So a is 7 and b is that. So a is equal to 7 is lowercase b. B is equal to 1.438. So that is your answer. I'll see you in the next video.